Hello, I'm Mr. Schwanenkamp. We are back. We are doing greatest common factors today. So a couple things we're going to do with that. We're just going to factor out greatest common factors, and then we are going to use GCFs in order to solve. This allows us to solve functions that maybe not are bigger than x or x squared. We're going to do some x cubes in here and maybe even some x to the fourth, depending on the problem. But we'll kind of see how that works. Nothing too crazy. You've probably done GCF before back in Algebra 1. We're just going to put it in a little bit different context today, but for the most part, pretty much the same thing. All right, let's do it. Shouldn't be super long. And the key to GCF is finding what something shares. So if you had a problem like 6x squared plus 15x, you're going to find out what they both have. Well, they both have a 3x in them, so we could take that 3x out in front, and the key is to divide both things by 3x. So 6x squared divided by 3x would give me 2x. 15x divided by 3x would give me 5. And then just like regular factoring, you are going to take both parts, set them equal to 0, and solve. So take out what they have in common, write it in front of the parentheses, solve each or set each part equal to 0, and solve. It's factoring. It's just a different type of factoring. Here we go. X cubed plus 5x squared. So what do they both have in common? Both of them have an x in them. In fact, both of them have an x squared. So I'm going to divide both things by x squared. That means I'm going to factor an x squared out in front. If I took x cubed divided by x squared, I'd have x. 5x squared divided by 5, the two x squareds would cancel, leaving me just 5. We factored. Once we've factored, we're going to take each one and set it equal to 0. X equals 0, x equals negative 5. Boom. Done. Those are my two answers. Technically, this answer is happening twice. When you square root 0, you get 0 two times. But that's why we're getting 3 answers when it's cubed. But we're good. Number 2, same thing. We're looking at it, x squared minus 9x. This is an easy one. What do they both have in common? Well, they both have an x. So I'm going to take an x out in front. If I take an x out of x squared, I'm left with x. X out of negative 9x, it's negative 9. Take each one, set it equal to 0. That's already done. X equals 9 is my other one. I'm good. X equals 0, x equals 9. Number 3, take out what they both have in common. Well, they both have at least one x, and I think you can only take out one x. So we're going to divide out 1x. When I take that 1x out of x, I'm going to be left with x squared. I take a 1x out of 49x, I'm going to be left with plus 49. I set each of them equal to 0. This one's done. This one I'm going to subtract 49. And then I'm going to square root, square root of a negative number. So x is going to be equal to plus or minus 7, because that's what the square root of 49 is. But I need to include an I in there as well because I took the square root of a negative. Again, notice how many answers we're getting there. We're getting 3 answers. It was an x cubed. Okay, this one was an x squared. We got 2 answers. Again, that's called the fundamental theorem of algebra. Whatever your biggest exponent is, that's how many answers you're going to have. So this one's going to have 3 answers. X cubed plus 9x squared plus 14x. I'm going to divide out of everything what they have in common. They all have an x, so I'm going to take an x out. I'm going to be left with x squared plus 9x plus 14. X equals 0. I'm going to factor this guy. X plus 7 and x plus 2. X equals negative 7. X equals negative 2. 1, 2, 3 answers. I'm good. Number 5, take out what they have in common. Take an x out of both. If I take an x out of that first one, I'm going to be left with x squared minus 25. Set each of them equal to 0. I'm going to add 25, take the square root, plus or minus 5. Again, there's nothing super crazy about this. It's just a matter of understanding what's going on. Both of these I can divide out in x squared. And so I'm going to get x squared equals 0 and x plus 16 equals 0. So I get x is equal to 0 and x is equal to negative 16. Again, that answer is really happening twice because it's squared, and that's happening once. There are 3 answers. All right. I don't think there's anything crazy. I think we've done all of the things we would want to look at. Maybe the only one we want to see, let's look at 9 here. I don't want to just do problems just because. X cubed minus x, divide them both by x. So I took out what they have in common. If I divide x out of x cubed, I'm left with x squared. X divided by x is going to get me -1. I'm going to take each one and set it equal to 0. This is just 0, done. This is going to be x squared is equal to +1. And then square root, x is equal to plus or minus 1. 2 answers there, a third answer there. We're good to go. We could do all of them. I think we've done enough, though. Let's go to the back side. So we're going to factor out the GCF. Same thing we did on the front side. The only difference is we're doing multivariable here. And so we've got x's and y's and z's and a's and b's and c's. It's not that much different. All right. So as we look at each problem, we're going to think, what can I take out of both? So I'm just going to go down the list. I'm going to look at the 2's and then the x's and then the y's and then see how much I can take out of each. So I've got a constant here. I've got this number 2. Can I divide everything in this problem by the same number? Yeah, 2 and 6, I can divide them both by 2. So I'm going to take a 2 out. My next thing I've got here is an x. It's got an x to the 8th. This one's x cubed. So how many x's can I take out of both? Well, I can take out x cubed because both of them at least have 3 x's, x cubed in it. And then my last one is y squared and y cubed. Do I have at least one y in each of them? Yes, I have at least y squared in each of them. So I'm going to take a y squared out. So that's what I'm taking out. So that is my GCF, 2x cubed y squared. And then what's going to be left over? Well, the 2's would cancel in this first one. X to the 8th over x cubed would be x to the 5th. The y squareds and the y squareds would cancel. So that's all that would be left in this first part is just x to the 5th. The second part, 6 divided by 2 is 3. X cubed divided by x cubed would go away. Y cubed divided by y squared would be y. That's what I wanted. Okay, so again, nothing crazy. We looked to see what they had in common and then divided it out, and that's what's left over inside of parentheses. Not any solving here. It's not equal to 0. We're just factoring out the GCF. So looking at the next one. What number can I take out of everything? I've got a 15 and a 10. What can I divide out of 15 and 10? Well, I'm going to take a 5 out because both of them are divisible by 5. Next one I've got is an x. This one's x to the 4th. That one's x to the 5th. So I can take out at least x to the 4th. I can't do any bigger than x to the 4th because that's as big as that one goes. Then I've got a y. This is just y. This is y to the 7th. So I can only take out one y out of each of them because that's as big as that one goes. And then my last one is z. I've got z to the 6th here. I've got z cubed there. So the most z's I can take out is 3 because 3 is the biggest one. So there's my GCF, 5x to the 4th y z cubed. And I'm going to look to see what I can take out here. So 15 divided by 5 would be 3. X's would cancel. Y's would cancel. Z to the 6th over z to the 3rd would leave me with z to the 3rd. Remember, when I'm dividing, I'm just subtracting exponents. Then 10 over 5. 10 over 5 is 2. X to the 5th over x to the 4th is x. Y to the 7th over y is y to the 6th. And z cubes are going to cancel. So I'm left with that right there. That's my answer. Nothing more than that. Just doing reps more than anything else. Let's do it again. What number can I take out of both? 3 and 12. Well, I can divide out each of them by 3. So I'm going to take a 3 out. A to the 5th, a squared. So the biggest I can take out is a squared. B cubed and b squared. So the b squared is the biggest I can take out of both. C to the 7th and c. So the most I can take out is just c. So that is my GCF. That is the greatest common factor. That's what they both share. Now I'm going to reduce. 3 divided by 3 goes away. A to the 5th over a squared is a cubed. B cubed over b squared is b. C 7th over c, c to the 6th. Again, just 7 minus 1 because I'm taking 1c away. 12 over 3 is 4. A squared over a squared. Those two a's are going to cancel. B squared over b squared. Those two b's are going to cancel. C over c. Those two c's are going to cancel. That is my answer. Done. Nothing crazy difficult about it. It's just identifying what is going on with each. All right, let's do one last one. Let's do this one. There's nothing wrong with the other ones, but I don't want to overwhelm you with just doing 8 billion problems. Some of you probably have already checked out. So let's do this last one. 8 and 10. What can I take out of both? Well, both of them are divisible by 2, so I'm going to divide by 2. This has an x cubed. This one doesn't have any x's, so x is not a common factor. It's not with both of them, so I'm not going to take out an x. I've got a y here and a y cubed there, so I'm going to take out just a y out of each. Z to the 4th and z. What can I take out of both? Well, just one z. So my GCF is 2yz. What am I left with? Well, 8 divided by 2 is getting me 4. X cubed, nothing canceled out with that. The y's cancel. Z to the 4th over z is z cubed. Minus 10 divided by 2 is 5. Y cubed over y is y squared. Z cancel. Done. That is my final answer. So GCFs are what we worked with today. Again, remember what a GCF is. It is a greatest common factor. Basically, what thing do both parts of the problem, or do every part of the problem share? And if you can recognize that, it's pretty straightforward. Hopefully that makes sense to you and you know what you're doing. If not, ask questions.